Hello all, today we'll be looking at a question given in GATE 2019. The chip select logic for a certain DRAM chip in a memory system design is shown below. Assume that the memory system has 16 address lines denoted by A15 to A0. What is the range of addresses in hexadecimal of the memory system that can get enabled by the chip select signal? We are given 4 options. The NPTEL video reference is lecture 15 on logic gates. Course name is Digital Circuits by Professor Shantanu Chattopadhyay from IIT Kharagpur. Now let us look at the useful data before solving the question. So a DRAM chip or DRAM is a type of semiconductor memory used to store data or program code which is needed by a computer processor to execute. The logic gate is a device that acts as a building blocks of digital circuits. It is a physical device which is used to implement a Boolean function. So a Boolean function is a function which gives the output as true or false. A Boolean function is a function which gives an output of either true or false. Basic logic gates and or not and XOR are known as basic logic gates which implement the functions and or not and XOR respectively. Now let us look at each of these logic gates with a diagram. The AND gate is represented by this symbol, shows that if both the bits are 1, the output is 1, otherwise the output is 0. The OR gate is represented by this symbol. It shows if either of the bit is 1, the output is 1. The XOR gate is denoted by this symbol. It shows that only one of the bits should be 1, then the output will be 1, otherwise the output is 0. The NOT gate is represented by this symbol. It flips the bit. So 0 becomes 1, 1 becomes 0. Now let us look at the solution. So we are given the address as 16 bits, which is A15 to A0. A15 to A11 is denoted by these signal lines, while A10 to A0 can have any set of addresses from 0000 to all ones. So A15 is 1 because you are sending it in the form of a direct input. A14 is 1. A13 you have to send 0 such that this NOT gate, this is a NOT gate, complemented input, or we can also say it's a complemented input. So if you give 0, then this AND gate will give me 1. So since this is an AND gate, all this address line should be 1. A15, A14 is 1. A13 should be 0 so that this complement is 1. A12 should be 0 so that the complement is 1. A11 should be 1. So I have written in this form. So replacing A10 to A0 with all zeros gives me the first answer, which is C800. So to convert this into hexadecimal, we group the bits into 4. So first set of 4 bits is 0000, which becomes 0. Then another 4 zeros become 0. Then 1000, which is nothing but 8 in 8 if you convert it into decimal. And 1100 is 12, which is written as C in hexadecimal. And replacing all x's with 1s, we get 1111, which is 15 in decimal or F in hexadecimal. Another 1111, which is 15 in decimal or F in hexadecimal. Another 1111, which is nothing but 15 in decimal, F in hexadecimal. And 1100 is 12 in decimal, C in hexadecimal. So the range of addresses is nothing but C800 to C triple F. I hope you all get this. Thank you.